Okay, so today, all right, we're going to continue on last Friday's, right? Last Friday's lesson was, our last lesson was on two-step equations, okay? Today, what you're going to see is it's actually a two-step equation, but you have some parentheses on one of the sides. Basically, one of the expressions is going to have a set of parentheses. And of course, a lot of times the way it's going to be set up is what we've dealt with before, is we're going to use the idea of distributive property, sort of. All right, so we'll talk about that here in a second. So, two-step equations while using distributive property. So, here's what I want you guys to do. Go ahead and I actually don't need you to do anything right now other than put down your pencils. All right. So, just take a look. I'm going to go to 484. All right, so on page 484, I'm actually going to do it on this paper here. Okay, on page 484, I'm going to take a look at number 2. All right, number 2 looks like this. It says, the sum of 4 plus g multiplied with negative 11 is equal to 121. All right, and they want to know, of course, we need to solve the equation by finding out what g is. So, really quickly, first of all, just realize that this negative 11, right, it has parentheses around it, because if it didn't, it'd look like minus 11. But realistically, and we've talked about this when we were dealing with expressions last chapter, remember this here could be flip-flopped and look like this as well. Means the same thing. So negative 11 times the sum of 4 plus g equals 121. Now, normally, right, we would see this and we'd say, oh, there's parentheses multiplied with some on the outside. This appears that I can use distributive property. Okay, so I could do that. I could say, okay, negative 11 times 4 is negative 44. Negative 11 times a positive g is negative 11g. So what I did is I just used distributive property, got rid of the parentheses, and that's going to equal 121. Now at this point, it's just last Friday's lesson. I can box in what we called our variable term, the term of the variable, negative 11g. I have negative 44 up in front of that, so I'm going to do additive inverse here. I'm going to add 44 to this side and add 44 to this side. Those cancel. We end up with negative 11g equals, and then I just add 4 plus 1 is 5, 2 plus 4 is 6. Okay? And then I'm going to turn around and say, okay, well, this is a one-step equation at this point. Box in our variable. I'm going to go ahead, and it's being multiplied with negative 11. Remember, we only do one inverse. That's the division part. So divide by negative 11 here. Divide by negative 11 here. And we end up with g is equal to, and then 165 divided by a negative 11. Well, first of all, positive divided by a negative gives us a negative solution. And then 165, let me clear this out. 165 divided by 11 equals 15. So g is equal to negative 15. So realistically, it's almost exactly the same from that dotted line down as from last Friday. It was just the distributive property part at the beginning. Now, like usual, so many of us love our basic ways, but I said, like I did last week on one of our other lessons, I said, guys, I actually have an easier way that you can do this problem. Not only easier, but less writing. All right? And let me show you what that way is. All right, so here's what we've got. We have sum of 4 plus g times negative 11 equals 121. Now, I'll call this step star, all right, but you don't have to write this step. But here's what I'm saying, and you don't have to write this at all, but when you can use distributive property, here's the skill that will work. I have this integer multiplied with this expression in here. Okay. Now, this expression actually is going to have, because of the parentheses, in the end, it really has one value because they're in parentheses. Now, what that allows us to do is we could say this times this equals that. Again, this times this. Well, because of that, here's what I'm going to do. I'm going to box in what I'll call my variable expression. It is being multiplied with negative 11, so I do the inverse. I'm going to divide by negative 11 here and negative 11 here. With those canceling out, I end up with 4 plus g is equal to, and then 121 divided by 11 is 11. Positive divided by a negative is a negative. And now we have a one-step equation. Box in our variable. Positive 4 is here. I'm going to subtract 4 from that. And from this side, whatever I do to one side, I do to the other. And g is equal to negative 15. If you take a look, much less work. A lot quicker. This happens to have basically, even though it's called a two-step, right? This lesson is, this has 1 step, 2 steps, 3 steps to it. This only has 1 and 2. It takes away a whole step. All right. This here is the way that we're going to do our work today. All right. Now, just to let you know, this way still works, but this is how I want you to practice on your homework. All right. Try to get used to it. So here's what I'd like you guys to do is go ahead, grab your pencil, and let's take a look at a different problem. Let's go ahead and let's take a look at problem number 1 on the same page. So page 484, problem number 1. And here's what we have. We have 2 times the sum of p plus 7, in parentheses there, equals 18. Okay, so as we have our pencils ready to go, I take a look. Now, I'll call this, again, step star, and that is, I'll put here for my notes, dp, meaning is there distributive property? If so, then here's what we're going to do for step 1. We're going to box in what I call our variable expression, what's in the parentheses. So p plus 7 is in parentheses. Okay, now this is going to look really familiar with these steps. So after that, step 2 is I do the inverse, right? So p plus 7 is being multiplied with 2, so I divide by 2. And of course, step 3, right? Whatever we do on one side, we do on the other side. So I'm going to divide this side by 2. Step 4 is I'm going to solve. So here we go. These 2's cancel out. I end up on this side. I can drop my parentheses, obviously. P plus 7 equals 18 divided by 2 is 9. And at this point, right, step 5, instead of going through all the little bitty steps all over again, this is a one-step equation. I'm going to put my little note there, 1 step. I'm going to solve it like a one-step equation. So I box in our variable, just our variable. 7 is being added to it, so I do the inverse. I'm going to subtract 7 on that side. I go to the other side, subtract 7 there. And when those cancel out, I end up with p is equal to 9 minus 7, which is 2. And there's our answer. All right, guys, questions on any of those steps? Nope, that's what I said. That's why I put a big star there. I want you to practice this way. If you get to the test and for some reason you kind of are drawing a blank and you forgot that, I'm okay solving it this way. It's going to take you a little longer, but for homework purposes, you have to use this way. I want you to try that out, practice that way. Okay, other questions? Say that again. Say it one more time. On here?
Yeah.
Well, we can't act. You're right. We can't simplify that, but that's why we left it like that. Instead, we used our addition property of equality. We just took the 44 off of both sides of the equal sign. So I didn't combine these two. That's why once we got down here, the negative 11g was still here. You see that? And then just added 44 on both sides. That 121 became a 165. Okay. So yeah. So I didn't. I mean, otherwise I would have gotten negative 55g, but I didn't. Right? Because if I combine those, that makes sense. Guys, when you combine like terms, you're combining like terms on one side of the equal sign, on an expression. Remember, that's what our last chapter was called, expressions. So when you combine like terms, you're only dealing with one half of it. Okay? But we're not combining like terms here. We're actually solving an equation by using this property here. It's a different math skill. Whatever you do to one side, you do to the other. And it helps us by getting rid of part of it. Okay? I understand. It's a lot, right? You're kind of connecting the dots, kind of putting things together and understanding. So that was a great question. Some of us may have wondered. Okay. But yeah, use this property whenever you're solving an equation. You do the same thing to both sides of the equal sign. But when you only have an expression, you're simplifying it, making it smaller, then you would combine like terms if you can. Okay. All right. Any other questions? Okay. Here's the problem I want you guys to try. On your homework, page 487, problem number 16. So you have to flip to page 487 to get there. 487, problem 16. All right, go.
Bless you.
All right, check it in. How many of you need more time on that? Okay. I'll give you another 30 seconds there.
Bless you.
Okay. How many of you still need more time on that problem? All right. Okay, checking in one last time. Anyone still need more time? Okay, a few more seconds. Okay, 30 seconds. Okay, when you share with your neighbor, a couple of things, okay? Obviously share your solution. And then also, please make sure that they're showing their work properly, which includes step 1. Make sure they're solving it this way. All right, so 30 seconds. Turn to your neighbor and share. Go. Thank you.
I got I got any
Anyway, so I didn't use
N equals negative 1.
All right, so for number 16, we had negative 28 equals 7 times the sum of n plus 3. Okay, so here we go. Just looking for some solutions. I'll write them up above here. Solutions that are out there. All right, C, not 31 in this class, C 22.
Okay.
And like that? All right, agree, disagree. What do you guys think? Okay. All right, others out there.
N equals negative 1.
N equals negative 1. Okay. Any others? Okay, well, negative 7 equals n would be the same, so you would agree with that one, right? Okay, any others? All right, well, let's check this out. So here we go. Negative 28 equals 7 times and the sum of n plus 3. I'm going to go ahead. Here's distributive property over here. There's my variable. I'm going to box in what I called my variable expression. This is being multiplied with 7, so I'm going to do the opposite. I'm going to divide by 7. I divide this side by 7, and I'm going to divide this side by 7. So these cancel. We end up with n plus 3 over here, once those cancel out. 28 divided by 7 is 4. Negative divided by a positive is a negative. Now it's a one-step equation. I find my variable, there it is. 3 is being added to it, so I do the inverse. I'm going to subtract 3 there. I'm going to subtract 3 on this side. And we have n is equal to. Now listen, I could tell by a couple of the more popular answers that maybe, just maybe, probably the issue that some of us are having anyway is adding, subtracting integers. Ladies and gentlemen, okay, if you get this wrong, that means you need to go back to do using the t-chart. So just a little reminder, remember at the start of the year, I said circle your integers with the signs in front. Okay, remember this, first of all, this isn't multiplying or dividing, right? It's negative 4 minus 3, so that's when you use a t-chart. Both of these are negative, meaning they both go on the same side of our t-chart. And remember, if they're on the same side, with a t-chart, you add them up and you keep the sign, so it ends up being negative 7. Okay? All right, so questions about that? Don't be scared to use your t-chart to be accurate, guys. All right, until you become comfortable. That you want to try to, the goal is to be comfortable with that before you move on to 8th grade. Okay, let's take a look at another type of problem. All right, it's very, very similar, just probably a step up in difficulty, even though I don't find it too difficult. And that is, let's take a look. Let's flip back over to page 484. Let's take a look at problem number 3. So problem number 3, it is the sum of v plus 5 times the fraction negative 1/9. And that expression is equal to 6. Okay? So here we go. You're going to see me do the exact same steps. Step 1, right? Box in. I could use distributive property. So I'm going to box in our variable expression in these parentheses here. This is being multiplied with negative 1/9. Now remember, I can divide by negative 1/9, but like we talked about last week, we're going to try to save ourselves some time. Instead of dividing by this, we're going to keep flip change, or basically the flip and the change right now. So instead of dividing by negative 1/9, we're going to multiply, change the multiplication, and I'm going to flip this, which becomes negative 9 over 1. Okay? Whatever we do to one side, we do to the other. Now listen, I'm going to be thinking ahead here. I could put negative 9 over 1 if I want, but ladies and gentlemen, that is negative 9. I'll just put negative 9 down here. So, where I did this here, those cancel each other out. On the left side, it's v plus 5. equals, and then on the right side, 6 times 9 is 54. Positive times a negative is a negative. And now we have a one-step equation. Box in our variable. It's on the left side. I do the inverse, subtract 5. Do the same thing to the other side, subtract 5, and I end up with v is equal to, now they're the same, right? Just like we were doing over here. I add them up and I get negative 59. All right, so just like dealing with a fraction coefficient. Any questions on that one before I have you try one like that? Okay, back to page 487. Try out problem number 20. Actually, you know what? I'm gonna pause right there. I actually want to do one more with you guys, and maybe let you try this one. What I want to do is let's go ahead and take a look at page 44. Stay on 44 if you haven't changed it already. Let's take a look at problem number 5. Problem number 5. Okay, on 44, problem number 5, let's go ahead and close read number 5. All right, here we go. Mr. Singh had
3
sheets of stickers. He gave 20 stickers from each sheet to his students and has 12 stickers left. Write and solve and to find out how many stickers were originally on each sheet. Now, listen, the reason why I wanted to make sure I do this with you guys is because we're going to use a bar diagram. We're going to write this equation, but more than likely as a 7th grader, this is one of your most challenging type of equations that you're going to have to write. All right, so let's go ahead. Let's do step 1, and you're going to see most of these steps are just like any other time we use a bar diagram. So step 1 is draw your bar. Okay, now step 2 is, remember, I always put the word total here. Now, there's an issue with this problem that's a little more challenging than some of your other problems. The issue is that it's going back and forth in this problem about the total amount of stickers versus how many stickers are on each sheet. Okay, so you have 3 sheets of stickers, and you have all the stickers, and then you have each sheet. So here's what I want to point out, okay? In this case, the total is actually the total amount of stickers. And in this case, if we take a look, the total that they're going to be talking about is the total amount that is left, and that is the 12 stickers. So our total stickers that are left are 12 after he gives them out to his students. Okay, now remember with step 3, the expression that we write on the bottom is going to match or equal the top. Well, on the bottom here, if we take a look, the best way to start this is by looking at what the question's asking us for, because that is going to be our variable. The question says, or I should say the statement, but what they want us to solve says, write and solve an equation to find out how many stickers were originally on each sheet. How many stickers are on each sheet, meaning one sheet? I'm going to let X be the amount of stickers, just the variable, that's our unknown, that's what we're trying to find out, on one sheet. Now here's the thing. Mr. Singh gave 20 stickers from each sheet. Now if you're giving out, or let's say the teacher, right? I'm giving out 20 stickers. What does that mean operation-wise, guys? What am I doing? I'm giving them out. Am I multiplying by?
No.
I'm subtracting by 20. So I have how many stickers on the sheet, and I'm giving away 20 stickers off of each sheet, right? This is all about each. That's what X is for one sheet. So I had so many on one sheet, I'm giving away 20 off of that sheet. That's what that means. Now here's the issue. The 12 is the total amount in the end on all 3 sheets. We have to have the bottom match that. So if this is one sheet, what do we need to do with this to make it 3 sheets?
Multiply.
Julian says multiply. Guys, if I multiply by 3, put like a dot and a 3, that would be wrong. This whole thing is one sheet. I need to put parentheses around it. And I multiply that whole thing by 3. This is how many sheet are on one sheet. I multiply by 3. This expression is how many are on all sheets. That is going to equal the 12. And that's what I'm going to do. Step 4. This part, of course, is like any other time. The bottom expression is equal to the top expression. From here, I'm going to go ahead and I'm going to solve. And guys, this is our lesson. So here's your equation, right? That is an answer, by the way. I'm going to go ahead, box in our variable expression. It's being multiplied with 3, so we divide by 3. Whatever I do to one side, I do to the other. I end up, when those cancel, x minus 20 equals, well, 12 divided by 3 is 4. And now this is a one-step equation. X minus 20 equals 4. Box in my variable. Inverse of 20, add 20. I'm going to add 20 to the other side. And we end up with x is equal to 24. We'll call this step 6, right? It is 24. Well, reread it. It says how many stickers were originally on each sheet. So it's 24 stickers. Now, it doesn't hurt. Here's your solution. It doesn't hurt to say, okay, if there are 24 on the sheet, he gave away 20 off of that one sheet, right? How many would you have left? Total of 4 stickers. You take that 4 on each sheet, and there's 3 sheets, right? 4 times 3 is equal to 12 that's left over. So that would be correct. So here's your equation that before we started solving it, and then your solution.